Hello, welcome to this revision on volume and surface area. I know it may not be a favorite topic to some of you there, right? Now formulas will be a problem to some, but it's best to learn volume and surface area with a meaning, with an understanding. Now for example, if I want to find the volume of a pyramid, what is a pyramid? A cone is a pyramid, a cone. And a cone, as long as it takes the shape of a pyramid, is the area of the base times the height, and you divide by 3. So like a cone, the area of the base will be pi r squared, multiplied by the height, and you divide by 3. Because it gets reduced when it becomes a cone. The whole thing is shrunk by 1/3. That's why it's AH over 3. Unlike cylinder, the whole cylinder, that's a prism. And the area of prism, if you look at it, is the area of the base times the height. That's all. And if the base is a circle, it's pi r squared times h, like a cylinder. Alright? So you find the area of the base multiplied by the height. And if you have a cuboid is actually it can be a square base or a rectangular base, but it's got a height. Alright? Unlike a cube, the length, base, height are all the same. So a cube and a cuboid are both prisms. Alright? Not a pyramid. But a pyramid can be if I have a rectangular shape and they all come to meet at a point right up there. It comes to a point. That's called a pyramid. Alright, let's look at an interesting sum here. And that sum here is the diagram below shows 3 containers A, B, C. Container A is made of a hollow cylindrical tube of height h joined to a hemispherical bowl of radius r, and the container is 81 pi cm cube. Now the capacity of this hemispherical bowl is 2/9 that of the whole container. Alright, it's 2/9. Find the value of h and of r. Let's go to this part of the sum and let's see what can be done. Now look at this figure here, this figure A, and that's what they're referring to. Now this bowl is 2/9 of the total volume. And what's the total volume? The total volume is 81 pi. So the volume of hemisphere HS, let me write that way, short form, is 2/3 of pi r cubed. A whole hemisphere is 4/3 pi r cubed. 4/3. Here it is 2/3, half of it, half of 4/3. And this hemisphere is 2/9 of the total volume of 81 pi. The whole volume here is 81 pi. And that's equals to 2/3 pi r cubed. Now you can cancel this pi off when you bring it down, gone. And you can cancel the 9 and the 81, you get a 9. The 2, when you come here, gone. Alright, anyways, let's look at it as 18. 18 times 3 divided by 2. Alright, you get your r cubed. Bring the 3 up, bring the 2 down. You can cancel it off and you get 9. 9 times 3 is 27. 27 is equal to r cubed. So your r will be the cube root, and that will be 3 cm. Hiba. Got it? Alright? Now they want to find the height of this container. Now you know this is actually 2/9, and that will be 7/9. The volume of this, because this is 2 is to 9. 9 is the whole thing. This will be 7 units. Alright, this 2 units, this will be 7 units. So it is 7/9 of 81 pi. So if you look at this here, high cylinder, this is the cylinder area of the base times the height. Remember, this is a prism. If I cut, I get the same cylinder. Alright, the same shape, the circle. So in a prism, it is area of the base times the height. I'm just talking about the cylinder. In this case, it's pi r squared, the base, times the height. And what is this volume equal to? You've got here, which is 81 pi, and this is 2 parts of it. We divide it 2/9, we divide it by 9, and you multiply by 7 because this is 7/9 of it. So we could cancel it, and we've got it as 63 pi. You got it? So that's 63 pi. Just put it down. Once you've got that, the pi and the pi could go off, and you've got 63 here equals to r squared h. The radius is found out, which is 3. And so r squared is 9. So 63 equals to 9h. And what is h going to be? 63 divided by 9, you get 7. So the height of it is 7 cm. Alright, 7 cm. Alright, so you've got the radius, which is 3 cm, and the height of this is 7 cm. You got that? Great. So that's the height of the cylinder, h. They wanted to find out the h. You look at the sum again, they said the hollow cylindrical tube of height h cm. So you are referring h to the height of the cylinder, and that is 7 cm. But if you look at the total height of container A, it is 3, radius is 3, this is also 3 cm, 3 plus 7 will be a 10 cm height. Now, let's look at the second part of the sum. A similar container A is constructed. A similar container to A is constructed and has a capacity of 216 pi cm cube. Calculate the ratio, alright, the ratio of the radius of container A to the radius of the new container. Now when you say the word they're similar, the ratio of the volume, if you look at it, my dear friends, similar figures, V1 over V2 equals to L1 over L2 cube, the ratio. Alright, V1 over V2 equals to L1 over L2 cube. Where L is the radius, it can be a ratio of radius, R1 over R2 cube, H1 over H2 cube, and what's the other one? Circumference, C1 over C2 cube. As long as they are similar. Now this has got, A has got 81 pi cm cube, whereas this new container is 216 pi. So when we do that, we look at it, we say A, V1 over V2, alright, will be equal. We want to find the ratio. Alright, let's look at that. I'm going to take this part of the board. I don't have much space, so I'm going to use this. Now V1 over V2 is actually, if you look at this, is 81 pi over 216 pi, and you cancel pi off, and that's equals to ratio R1 over R2 cube, the ratio. Alright, so we look at 81, we can find the cube root if we can, will be good. Now R1 over R2 will be the cube root. And if you look at 81, 81 is actually 3 to the power of 4. 81 is 3 to the power of 4. And 216 is 6 cubed, 6 to the power of 3. And you've got R1 over R2, which is cube. Alright? Now let's see how we can reduce that and change it. Now, what is 6 made up of? 2 times 3. I know you can use your calculator, but I'm trying not to fall back on the calculator. 2 times 3 cubed, right? That is 6 cubed. 6 is 2 times 3. So you've got, look at that. You've got this whole thing. 6 cubed is 2 cubed over 3 cubed. We could cancel this off. 3 to the power of 4. 3, 4 times 3 cubed. Cancel the 3's off. You get 2 over 8. And when you find the cube root of R1 over R2, the ratio of R1 over R2, let me get the space here, all right? So you can see that R1 over R2 will be the cube root of 3 over 2 cube. You got that? Cube root of this will be 3 over 2 cube. And we could put it in exact value. It will be a root 3 because we can't find root 3. And this 2 cube will be 2. So when we talk about ratio, what do we mean by ratio? R1 to R2 is root 3 to 2. That's the ratio, the exact value that we are talking about. Now, that is the ratio. Are you clear? We're talking because this is never ending. And if you were to put it in your table, all of you look at it here, root 3, cube root 3, cube root of 3, divided by 2. I'm just getting you the answer for it here. You get 0.72111, and if I were to put it as a fraction, how do I put it as a fraction? Because this is a recurring decimal. All right, we get a cube root of 3. I'm just trying again, divided by 2, and we get an answer here, which is 0.7211, which is about 72 over 100. Okay, roughly, approximately. So this answer here, I want to tell you, it will be 0.7211. All right, it is 3 significant figures, which will be 7 to 1 over 1,000. The ratio will be 721 is to 1,000. If you were to write it that way. If you want exact value, you put it this way, or you put it as 721 is to 1,000. Is that clear? All right. So left to how you want to present your answer, and since they put it either way, I would accept that right. And this is just a revision, just to reinforce the concept of volume. All right, surface area. All right, more than getting this, I want you to understand how we derive it. The volume, the ratio of radius, V1 over V2 equals to R1 over R2 cube. And you look at that, you find 81 pi over 216 pi, cancel it off, and then you can find the ratio. Now we can also go directly into it. Calculator, please. If you're using calculator, you can find the cube root and put a bracket. I'm going to press square root, press cube root, and put a bracket 81 divided by 216. All right, and then get your answer, and you will still get the same answer. All right, 0.7211. And if you talk about the word concept ratio, this is just 0.721. This does not show ratio. Ratio shows R1 is to R2. All right, so that's why I would refer this would give me exact value, or when this you get 0.721, it means 721 is to 1,000. That's the ratio. All right, now we talk about area. What about area? The ratio of the new container to the old container. How do you go about that? Now for area, we look at if they're similar. We get A1 over A2 equal to R1 over R2 squared. A1 over A2 equals to R1 over R2 squared. And we've got the ratio of R1 over R2, which is root 3 over 2, right? And you square it. When you square it, you get here 3 over 4. So that's the ratio of the area when you keep it to its exact. So ratio of area A1 to A2 will be 3 is to 4. So therefore, A1 to A2 is equal to what? 3 is to 4. This is how you write ratio. Alright? Okay, good. Now, if I were to put this way, I get 0.721. Alright? And if I were to square it, and what I get, I will have to get that answer. Square root 3 radius divided cube root 3, sorry, it's cube root 3. Oh, I've got a mistake. All of you look again. It is ratio. I've got 8 over 2 is a cube root of 3. I'm sorry about that. Now this is not a square root, it's a cube root. So let me see whether I pressed it right. A cube root of a 3, yep, divided by 2. And what do I get? Yes, this part is no problem, 0.7211, which is this. Now here I made a mistake. This is cube root. You see, I did not. Kumar, right. It's a cube root of 3 is to 2. Alright, that's a ratio. So if I look at it, this is a cube root, alright, of a 3 over 2. So let's look at it. When you square it, okay, a cube root, the ratio will not be 3 here. Let's look at it here. The 2 squared, the below will become a 4. So what will that be? Cube root of 3. When you square it, you get 3 to the power of 2/3, and this is 4. Now 3 squared is 9, is a cube root of 9 over 4. So the ratio of A1 to A2 is cube root of 9 is to 4. And if I were to use the calculator, 9, cube root of 9, divided by 4, alright, and what we get is 0.52. This whole thing is actually 0.5200. Now this would mean 52 over 100. Are you all clear? So I could write like this for exact value, or I could write it as 52 is to 100. And I could reduce it again, 26 over 50, and reduce it further. So I get 52. Look at that again, divide it, I get 26 is to 50, and I divide it again, the ratio, I get 13 is to 25. Now everyone test for me 13 divided by 25, and we've got this answer here, 0.52. This is an approximation, the ratio of the area, 13 is to 25. Now again I repeat, alright, look at the careless mistakes as abundant in volume. Alright, they're writing in a hurry. And then it's because I come to check, I say, oops, the square root became mistaken. The cube root became mistaken for a square root. Though the answer here, you look at that, cube root of 3 is still cube root of 3 over 2. Alright, ratio is cube root of 3 over 2. And the ratio will be 0.721, which is this. 0.721, which is 721 is to 1000. Or I could leave it in the exact value for the radius. As for area, it's R1 over R2 squared. Cube root of 3 over 2, you square it. And the cube root is actually 1/3, and then you square it, it becomes 3 to the power 2/3. And here when you square the 2, you get a 4. How do you express this? 3 squared is 9. Here's a cube root of 9 over 4. Now you can express it this way for a ratio, for exact value, or you could put it as, what is 52 cube root of 9 over 4, you get 0.52. And it goes on a little bit for 0.5200. So if you express it as 52 is to 100 area, and then reduce it, you get 13 is to 25. Now either way you could put your answers. Now, but the concept that we are driving at here is when two figures are similar, alright, when two figures are similar, the ratio of sides, ratio of figures. A1 over A2 is R1 over R2 squared. Alright? Now let's move on. Water is poured into an identical container B like A, and I'm afraid this height, look at it, change it to 7. Alright, this is an error. 7, and the diagram should be 7 cm as shown in the figure. Calculate this whole thing, 7 cm as shown in the figure. When we say the word identical, it means look-alike. Alright, this correction is already done in your paper, so when you get your notes you can see that change. Now, water is poured into this identical container B. Identical means it is the same shape. Alright, the height from here to here will be 7, and then the here will be 10. So if you look at this height is 3, alright, 3 cm, as the radius is 3. So what will this length be then from here to here? Here you got 7 from here, from the bottom up. Okay, so this will be 4 cm. Alright, so the water is poured into this container, the same container here, and they ask us to find the volume of the water. Now that makes it a lot more easier to find the volume of the water. The volume of the water is made of, there's two shapes here. Two shapes. It's a cylinder and it's a hemisphere. So volume of water, you want to find the volume of the water in the cylinder, and you find the volume of the water in cylinder. Alright, you can write it as water in cylinder plus the volume of water in hemisphere, HS. So, well, that volume of the water, W, is that right? The shape of this cylinder is pi r squared h. Alright, I just want to put here pi r squared h, and this is 2/3 pi r cube. Now, if you look at this, height is 4. So we've got 4, the radius is 3, but earlier on we worked out this whole volume, which is 2/9 of this total volume. That came up to about 18 pi, 2/9 of 81 pi, the total volume, because these two are identical. So this whole thing is filled up, alright? 2/9 of 81 pi is 18 pi, okay? And here is pi, the radius here is 3, 3 squared is 9, and the height here is 4. So you've got a 36 pi plus a 18 pi, 36 plus 18, alright? A quick calculation, if you look at it, I would add 20 and minus 2. So it's 56, 56 minus 2 is 54 pi, and so that will be the water, pi, 54 pi cm cube. Now express it to 3SF, alright? Press it, 54 times pi, I need to look at my, alright? Many of you are very quick, I know. With your fingers, and you got the answer, and put it to 3SF, it gives you 169.6 cm cube. That's the volume of water. But if you want it to 3SF, it's 170. Alright, please correct that to 3SF if they're required. So this is how you work out the volume of the water in the container. Now, once you've got this water, they say in question C, let's look at that. The water from B, container B, is transferred to container C, and it's a right circular cone. Find the height of the water in the cone if the radius of the surface level is 7. This radius here is 7 cm. And what's the height of this water in the cone? And the height of the water here, I'd rather take the exact value, 54 pi cm cube. Now this 54 pi cm cube, this water is all emptied in here. So the volume of the cone is actually pi r squared h. General formula, I'm just getting the general formula because it takes the pyramid shape. And this is a water pyramid. This is look at shape water cone. Alright, so this is the height of the water cone. This is the radius, which is given to be 7 cm. So what we've got is here is 54 pi. That's the volume of the water. And here you've got pi. R squared we don't know. Radius is 7. Yes, so this is 7 squared, which is 49. And you have a h over 3. Remove the pi, bring the pi over, papa. And so what you've got is 54 times 3 divided by 49, and that's your h. Alright, so work that out. 54 times 3 divided by 49, papa, and you get 162 over 49, and that means it's 3.3. 3.306, alright, cm. That's the height of the water level. Alright, if you want to 3SF, the height of the water is 3.31 cm, nearest three significant figures. Alright, in volume, there's lots of calculations that's involved, and being careful is one thing. Alright, and I gotta remind myself too sometimes, and it's very important to look at what you're looking at, get the formulas right. You fit in the wrong formula, you get the wrong thing. Alright, and understand the question. They said, hey, find the water level of this cone. This whole water is going here, and we know that the water is 54 pi. Why should I take 170 cm cubed when I could take 54 pi? And there's also a pi here, which will be eliminated as we remove it, okay? As we try to solve for h. So look at that very simple reasoning. In your height is 3.31 cm. Right, now this sum teaches us a few things. There's a few shapes here that's to do with a cylinder, a hemisphere, a cone. And I like it because there are 3 different concepts of volume, 3 shapes: cylinder, hemisphere, cone. And over and above, it's so dense, the sum. They're asking you the ratio of radius, the ratio of area, and not to panic about numbers. That you say, oops, what am I gonna do? Now you see a sum like that, right? That's the exact value. Look at that, the ratio of radius. You've got cube root of 3 over 4, that's for area. But for radius, we got earlier on, radius, we got the radius as cube root of 3 over 2. Alright, that's a radius formula. So do not panic over it, and then you just work this simple thing out. These are things that you may see in your paper. Alright, here you can put it as exact value. This is to round it off to nearest. Alright, the ratio. Now we also have a ratio of area of 2 figures, and we also found out water is poured into an identical container. That means they have the same shape, same volume, same surface area, and this water is here. Water level is of such a level, 7. Alright, that includes from here 3 and here 4. Alright, so it's 2 parts of the shape, and this volume is already determined here. It's 2/9 of 81 pi. So we've got that, and all we need to do is to find this volume and add about pi r squared h plus 2/3 pi r cubed, and we've got this beautiful answer. Radius 9 times 4, the height 36 pi plus 18 pi, 54 pi, and that 54 pi is poured in here. This volume of this water is 54 pi. And so what is 54 pi? Pi r squared h over 3. And then we work it out. Alright? So much for this sum. And we move on to question 2 courageously. Okay?